All right, we're live. Let me check the audio real quick. All right, we're live. Perfect. All right, so we sound good. All right. Hello, everyone. Thanks for tuning in. We have a beyond awesome stream for you guys today. After the list of things that we're going over today, you should have all the basic fundamentals. Like if you go to the C# documentation on C#, there's gonna be a couple things that we won't cover, just because I don't personally think they're necessary or they're too generic for C#, and they'd be better learned elsewhere. But for the main C# concepts, we will have covered just about everything that you'll need to be able to start working on your own application. And then after this, we'll start working on more esoteric concepts. Esoteric meaning more geared towards some sort of specialization. So this stream, we're going to be learning about interfaces, lambdas, and then grouped together will be generics, collections, and link. After that, we'll learn delegates and events, and then finally, we're going to talk about documentation. The next stream, I'm planning on talking about making web requests, how to do asynchronous programming, and how to work with all sorts of HTTP processes. So tune in for that one as well. After the next stream, after the HTTP and async stream, I'm planning on moving into probably some ASP.NET stuff. So we'll actually set up like a web server using all the concepts that we've learned so far. I'd like to start, I don't know, we'll set up some dummy project where, like, I don't know, we'll hold customer data or something. So that way, we have like a playground for you guys to test all these cool things that we're learning. For those of you that are unaware, in the description of each of the live videos is a link to the Github repository, and in the Github repository is a folder for each of the individual projects. When you download the Github repository, it will look like this folder, and when you go into this folder, you'll see C# tutorial 1, 2, and 3. If you want to open up one of the tutorials, you just double-click on the solution file, and that'll open it in Visual Studio. Okay, so the first thing we're going to talk about today is interfaces. So an interface is basically a way for you to group related functionality that like some sort of class or struct must implement, right? So an interface would define static methods or methods that would be inherited, um, and it could declare like default implementation for how things would handle it, or it can just say here's the method. If you implement me, you have to do something with it. So we're actually going to go back to what we made in the first stream. If you haven't seen it, basically what it is we made a zoo. So we have classes. The top level class is animal. Under animal is dog and lion and cheetah, right? And then basically what it does when if you just hit run, every X number of time, depending on the class, a dog would say woof after every 3 seconds, and something broke. Apparently I didn't leave it in a working condition. My bad. So basically what I wanted to do is the plan is to go through how this guy is currently set up and change the all of the classes have this make noise function, right? And it is all inherited from the parent make noise function. The make noise function is abstract, meaning that the animal doesn't make a noise, but a cheetah, a dog, or a lion would make their version of a noise. So a lion would say roar, a dog would say woof, and a cheetah would, I don't know, growl. So let's say, for example, that maybe we're going to have something that's not an animal, right? Maybe we're going to have, I don't know, a clock, and it's going to make noise. Like it'll print tick, right? Or tick tock or something like that. Well, if we want to hold a group of all these things that make noise, right? So maybe we don't have a zoo, maybe we just have a collection of things that make noise, right? Well, if we want to say, in this case, the example doesn't make a ton of sense, but we're going to hypothetically talk here. So currently what happens is you wait some amount of time, you check if the animals are hungry. If they are hungry, they make some sort of noise, and then you feed them, which resets their timer, right? So let's say, for example, we no longer have a zoo, and we're not looping through a zoo every hour or so. We're looping through a just list of, like, I don't know, household objects, which happens to include zoo animals for whatever reason. and the household object that we have would be like a clock, right? And what we want to do is we want to basically say, for each one of those objects, tell it to make noise if it's supposed to, right? Well, if we were to have just animals, it would make sense that the top level animal class have some sort of function that the rest of them can inherit. Well, the point of interfaces is that we have two completely separate objects that have nothing in common other than the fact that they do X, right? It's an interface, right? Like your mouse is an interface between you and your computer, right? You and your computer have nothing in common other than this interface, which would be your mouse, keyboard, and monitors, right? The interface between an animal and a clock is that they both make noise, right? So if we go make an interface, it would look something like this. We go to add to the project, and we're going to create an interface. And the syntactical expectation of interfaces is it starts with the letter I. So we'll call it I make noisable. No, that doesn't make sense. Usually you add the word like able because it's like capable of doing something. So like if we were having flying objects, it would be I flyable or I somethingable that saying that it has the capability to do this thing because all you have is functions inside of it, right? So we'll say it I don't know. We'll just say printable for now because it can print something out to the console. Okay, so an interface. We'll get rid of the namespace because we don't need it. And we don't need any of this extra crap. Okay, so if you hover over the interface, you can see that it tells you it is of type interface. And all you want inside of an interface is the methods that it's going to have. So our functions were make noise. And if we go to animal, you can see the return type was void, and the parameters that the function took in are none, right? So we're going to keep the same strategy here, but we're also going to make it public so that way others can call it. So, sorry, my bad. We can't do public for interfaces because they're going to be inherited to the children, and we can tell them if they're public, right? So basically what we're going to do is we're going to tell an animal now that an animal is printable. And we no longer need this make noise function abstract, right? Because now the children, if we just go to, I don't know, dog, you can see it has no methods that it found suitable to override from the interface, right? And so what that means is we're not overriding it from a parent class. We have an interface, right? So we can just, how do I make this make sense? Basically, if I were to get rid of this make noise function, if we go back up to animal. Okay, you see how iPrintable says animal does not inherit the interface member iPrintable.makeNoise, right? So we can show the potential fixes, and we can say we want to implement the interface, right? And it will automatically, copy in some interpretation of what it should look like, right? So we could say all animals are capable of making noise, and then we could also create a separate class called clock that's capable of making noise. And if we call so in zoo, we would no longer have a list of animals. I'm just going to clear this out just for explanation purposes. We'd have a list of printable, right? And we just call it, I don't know, a list of things, right? And so now we could loop through each of our printable things. And if we, I don't know, we'll call it printables. And now if we call printable dot, you can see, because it's printable, we have the ordinary object functions like equals, get hash code, get type, and so on. But we have this make noise function. You can see it comes from iPrintable, right? So now what this allows us to do is group things by a common interface, right? I feel like I'm repeating myself, but I hope it's making sense. The thing that we have in common is that we can both make noise, right? So this interfaces are really commonly used to handle, objects that it almost lets you say that I am not a subclass of this thing, but I have this property or this functionality, right? So I'm trying to come up with another example here. Okay, let's take this for example. We could have a car interface with an animal, right? And what would they have in common? Let's say movable, right? Like they have some way to move on, like let's say we have like a 2D screen or something, and so you'd call the function move, and an animal would move based off of its movement speed, and a car would move maybe based off its movement speed and how much gas it has left or something like that, right? Um, the goal is that you use interfaces when you're going to have common functionality between disparately um, classified objects. So if you have some functionality that you want to be able to group, like in this case, I just want to be able to tell all of my things to make noise, right? I don't care if it's an animal or if it's a clock or what it is. I just want to be able to tell it to do this thing, and that's kind of the beauty of interfaces. For Max and Alex that are in the chat with me, does that make sense to you guys?
Yes, mate, definitely. Although I was struggling to understand why you wouldn't just have like a better inheritance tree that could kind of cover. So maybe the cheetah and the car could just inherit from something else.
Ooh, that's a really good question.
You know what I mean? It seems like you could do exactly the same thing with inheritance, right? But it might be more complicated. Yeah.
So let me put it this way: an inheritance only holds functionality, right? Does that make sense? Because an interface only has methods that you I don't want to say override. I don't think that's the right word. I don't remember what the right word is off the top of my head. You implement an interface. Sorry, I should have known that. So you extend the functionality of the class, but you implement an interface, right? So like, the other nice part about interfaces is that you can implement multiple interfaces, right? So I could say an animal is something that's printable, but it's also something that's movable, right? And so I can have a car that isn't printable, right? A car doesn't print anything out, but it is movable, right? So you can grab only the functionality of the thing that you want and implement it. And then when you have a grouping of those types of objects, you now have some common functionality that you can tell them to do, right? On top of that, making a parent class, so I could have, instead of giving it an interface iPrintable, I could have had a parent class called printable that both animal and clock would have subclassed from. But if there's no properties that they have in common, right? What do an animal have and a clock have in common? Property-wise, nothing, right? I mean, we're speaking figuratively here. We could probably find something that they have in common. But in this theoretical
Both
hypothetical
have
case,
hands.
what's that?
They both have hands. No, I
Yeah.
was just messing about.
In this hypothetical case, they don't have any um, properties in common. They just have functionality in common, right? Um, what else would be some good
Yeah.
things to know about interfaces? Interfaces also don't provide any code, right? They just, all they provide is the method signature, right? You don't fill in the method. You just say here's the method and the parameters that it takes in and the return type, right? Which allows you to make it really generic so that um, a common example that I can think of would be something that's serializable. And this is something that we talked about last stream. Serializing means you can take it from an object and print it out in some human readable format. In the case of last stream, it was JSON, right? If something is serializable, maybe all objects are serializable, and you can call serialize on that object, but they don't have any properties in common, so you wouldn't have them inherit from a parent class because that would be extra overhead that you don't need.
I got it. So you can kind of pick and choose like the stuff you actually want without getting all the kind of the extra baggage.
Yeah. And let's say for example, if something is serializable, right, that means it can be encoded, meaning it can be written to a file or written to like an HTTP request, and you have decodable, which means you can decode it, right? So if you have a request coming in or a file coming in, you can turn that into an object. Well, maybe one of your objects is only encodable or only decodable, right? If you just have serializable, that encompasses both. Whereas if you have an interface, you could pick which functionality you want, right? So I also think that there are lots of good times where people should have used inheritance versus, or should have used composition, meaning using interfaces, over using inheritance, because once you get to this really high or really deep hierarchy of classes, it makes it really hard to find out, like, maybe in our case, animal has whether or not he's hungry, hours to hungry, and hours since feeding. Um, maybe the animal handles when he's checking hungry, or maybe a dog has some special functionality that handles when he's hungry, and then maybe like a golden retriever would have something more special. And then, like, as the hierarchy gets deeper, where all these things are handled can get confusing. Whereas if you have an interface, you can kind of say, I'm inheriting it, I'm the one who tells this thing what to do. And it's kind of hard to explain without like a large project or working on a large project. I want you guys to be aware of them so that you know that they're in your wheelhouse. Um, and as we start to do more projects together, when we get to the .NET or the ASP.NET, the web server stuff, we'll give you a lot more examples of classes and interface, and those concepts will become more concrete, pun intended. Okay, so any questions on interfaces before we move on?
Yeah, just about a class having multiple interfaces, and sort of how that works, and how does the class know which it's using, or can it just use different bits from either one and it just takes what it needs? Is that how it works? Or
Can you
um,
can you rephrase the question? I'm not sure I get what you're asking.
well, I think you said earlier that when you declare the class, you can say that it's going to be an implementation of multiple interfaces, didn't you?
Yeah, so I could say this
So
animal would inherit from iPrintable and iMovable.
yeah, exactly. And then um, so it's not bound to a particular. Um, does it have to implement everything from both, or can it just be like a mixture of the two? Do
If
you
I
see what I
if
mean?
I implement iPrintable, it literally means I just have to have the function. There could be absolutely nothing in it, or I could do whatever I want with it. Is that what you're asking?
Yeah, I think so. Yeah, you
Okay.
don't. Yeah, yeah. I think that explained it.
Okay. Sweet.
I'm good on my front.
What's that?
I said I'm good on my front.
Okay. Sweet. Okay, so I'm going to close this project. I'm not going to say any of the changes. Now we're going to get on to some of the more complex stuff. And if I lose you guys, feel free to stop me because I know this stuff took me a long time to understand. Um, and some of these things kind of overlap. Like link, you need to know lambdas first, and lambdas, you kind of want to know collections first. And collections, you kind of want to know lambdas first. So like some of these concepts, you're going to have to like see something that you haven't seen before, and then we'll have to go teach it and hopefully reteach you it again. I hope that makes sense. Okay, so I rather than taking the approach that we did the last few streams, I kind of already have some samples written up here because the syntax is a pain in the butt and I didn't want to look like a fool on stream. So what we have here is I just have the comments of what we're going to lay out. I have the main function with all of the functionality that we're going to be using just commented out, right? So we're going to start with lambdas, and I just broke them out into their own files, right? So a lambda, what is a lambda? A lambda is a it's literally a function without the declaration of a function. And the best example I can give you of this would be the different versions of lambdas that C# has gone through. So this is version 1 of C#, version 2 of C#, and version 3 of C#, how the syntax has changed over time. The C#3 lambda syntax is what's most commonly used now, but I wanted you guys to be aware of how it can look. So how does it work? So we declare a delegate, and a delegate is basically something that um, listens or responds to an event, right? And so we declare so a delegate is basically a function, right? It has a return type and parameters, and then the name of the function, right? And then you have the function that it calls when it does the thing, right? So you can kind of pretend like this is an abstract function, right? That doesn't have any implementation, but um, allows you to choose how the implementation is going to work. So we'll walk through an example here. So we create an instance of the delegate. We call it delegate A or test delegate A. And then we create an instance of that delegate and we pass in the function that it should call when the function is called, right? So you can see down here, I literally call the delegate like a function, right? You can see test delegate A, I literally call it exactly like a function. I give it a parameter that's a string, and then it just calls, right? And what does it do when it's called? Well, whatever you put in here, right? And what do we pass in? We pass in a function, right? Delegates allow you to pass functions as parameters. And what does that function do? It just writes whatever you sent it, right? So when we run this line of code, it literally calls the old delegate function, which just prints out whatever you passed in. So when we call this function, all it's going to do is print out, hello, my name is old delegate, and I write lines. So in C#2, they said, um, this syntax is kind of funky. I think we really want to get across the point that we want you to be able to do these things in line, right? Or write it all in one line and not have to, make another function, right? So in this case, the old delegate function is what's happening when the delegate is called. Whereas in this case, we literally write it like what that function does in brackets, right? So when we call test delegate B, it passes in I'm an anonymous function. It passes that in as the parameter, and then it prints it out. And then they said, okay, everybody's kind of moving towards this lambda syntax, which is kind of a way to write an expression. And so what you're saying is this delegate, when I'm called, what do? I take in a parameter, we're going to call him x, and what do I do with that parameter? The function, like the body of the function is this, right? So this is equivalent to saying string x, right? If we were using the same variable name, and then console.writeLine x, right? So this is converting from this format to this format, is what this is doing, right? So if I uncomment out this lambda versions function, and I hit run, all of these should do the same thing, right? They should all just print out what we pass in, right? You'll see that it says, hello, my name is old delegate, and I write lines, which is what the first delegate does. The second delegate says I'm an anonymous function, and the third one says I'm a lambda delegate, right? So a lambda really is this type of syntax. We're going to get to delegates later on. I don't want to go too deep into detail to them right now because they are complex on their own. Lambda is really this syntax right here. And so we'll get more into detail in that syntax. So the basics of a lambda, you have two types of syntax you can use. You have parameters, and then this arrow. In other languages like JavaScript, this is, for example, called an arrow function because, it has an arrow. And this is just the equal sign and the greater than sign. And so you can either give it an expression, right? Or you can give it like a series of expressions, like pretending it's a function, right? So in this example, we create an array and we give it 3 elements, 10, 20, and 30. And then we call array, which is a system implemented class, and they have this function called find, and we pass in the array, and then we say, I want to find the element where the element is equal to 20, right? So this just says, what do we want that variable named? And then over here, we say, what do we want to do with that thing that we have named, right? So I could have just named this ASDF, and as long as I change that inside the body, right, it still works, right? So this is basically saying, like, this is the parameter in the function arguments, and this is saying, like, what we're doing with it in the body of the function, right? So if I were to comment this guy out and uncomment this guy, all it should print out. Nothing. I did something wrong. Did I not close out last time? There we go. Okay, there we go. Sorry, I don't know what happened last time. So what it did, right, is we created this array, and did I show the syntax last time? Var? Guys, have I shown that before? I forget.
Yeah, you did, yeah.
Okay, cool. All var means is that we know what the type of the thing is on the right-hand side, so we don't have to say, int array. We can just put var because we know what it's going to be because we're declaring it right here. And so what this guy is saying is we are looking through the array and we want to find which element is equal to 20, right? And we know 20 is equal to 20, so it's going to print that out, right? And so what this function takes in, if we hover over the find function, it takes in the array that we want to search through, right? And it takes in a predicate. Well, what in the world is a predicate? If we scroll down to what we're going to talk about next, a predicate is a function that's used for validation. It returns a boolean, right? So this function loops through each of the elements and says, hey, Mr. ASDF, you're equal to 10 right now. Are you equal to 20? No. We'll go back through again. It says, hey, 20, are you equal to 20? Yeah, cool. Let's spit that guy out, right? Like this is a boolean statement, right? This is true or false. We're saying ASDF, are you equal to 20, right? We're not setting ASDF to 20. And when this returns true, we know we found the element in the array that we're looking for. So it sets that defined element and prints it out. Okay, and I know this is probably super confusing, and we're just going to keep going through more examples until it sticks. So we're going to do the 2 different types of lambda expressions, right? We talked about them right here. You can do parameters and then an expression, or parameters and then a list of statements. So we're going to do this first one right here. So there are 3 different ways that .NET allows you to kind of store these things, because really what lambdas are a different syntax to writing functions, right? The 3 ways that you can write them are an action, a function, and a predicate. An action, as the name describes, is literally just a pointer to a function, right? It doesn't it accepts as many parameters as you want, but it doesn't return anything, right? You're doing an action, but you're not giving anything back, right? A function would do an action and return something. Hence the difference in naming conventions. Okay, so for the action, what are we going to do? The name of the action, we're just going to call it print line. We're not going to take any parameters, and we're just going to write something out, right? We're just going to write out I am an action. And then an action is now, you can basically pretend this is a function of its own, because we're going to call it like a function. So basically what you're allowing yourself to do is you have this variable isn't serving as a pointer to a variable, it's pointing to what? A function, right? So this is probably a new concept to wrap your head around if you haven't seen this syntax before of a variable holding a function, right? This is a crazy concept and I love it because it allows you to do so many cool things that we'll get to in just a second. Okay, so I'm going to go change our comment to run our expression lambda types. And I just put a breakpoint here because I want you to see what's happening. So you can see we printed out I am an action, right, on the console.write line. And actually, I want to put the breakpoint right here so you can see what happens as we're stepping through. Okay. Ooh, I have to pause and restart, my bad. Okay, so we hit this line, and you can see we haven't printed anything out because we haven't executed this line yet, right? If I hit F10 to go to the next line, you can see I still haven't printed anything out, right? What is this line doing then? All it's doing is saying this variable, you are equal to this function. Whereas this line is actually calling the function, right? So when we hit F10, hold on, I'm gonna put this on a side window so I don't have to keep toggling back and forth, and then we will collapse you. Okay, so when we hit F10 now, it will actually call this variable like it's a function, right? So when I hit F10 and go to the next line, you'll see it called this function, which did what? It printed out I am an action, right? Okay, so now we understand what an action is, right? And these things aren't used terribly often, but I want you to understand what's happening, right? If you hover over, okay, I can't do it while it's running. My bad. We'll hover over it in a second, but it'll tell you what an action is. Okay, so the next thing that we're doing is we're creating a function, right? We're literally creating a function and setting it to a variable. What is our function doing? Well, it's taking in a parameter and it's adding it to itself, right? So our parameter's name is parameter1, and we're saying parameter1 plus parameter1. So we're really just multiplying that variable by 2. I'm just calling it self-sum because I'm summing myself with myself, right? So we go to next line, and we can see if we hover over self-sum and we look inside of it, we have the method that we're implementing, right, which has a bunch of variables and crap inside of it, and then we have the target of that method, which is the lambda itself. That's the target of the method, right? We're targeting this lambda and saying you're going to do the thing when we want you to do the thing. So when we hit next line, you'll see that result is equal to 4, right? Because we said, hey, Mr. self-sum function, we're passing you in 2, right? X is 2, and so if we pass in x and we pretend that's param1. Then we do 2 plus 2, and that's 4. So you can see our result is set to what this function returns, which is 2 plus 2. Okay, so now we're getting a little bit more complicated, and basically what the func version or what the func function or class does. If I go to C# func, you can see it has a T and a T result. And we'll get to talking about generics in a second, but basically what this means is you can fill this in with any type, right? And then so you have something that you're passing in and you have some result, right? In this case, we're passing in an integer and we're returning an integer, right? In the second case, we're passing in 2 integers and we're returning a double. So we're passing in param1 and param2. And then we're saying, let's take 1 to the power of, or the first parameter to the power of the second parameter. So when we call the function, we're saying we're taking x to the power of y, or 2 to the power of 3. So 2 times 2 times 2, pow result should be equal to 8, right? You can see when I first start it's equal to 0 because we haven't executed that line yet. When we execute the line, we get 8, right? Because we're taking 2 to the power of 3. Does what I've talked about so far make sense, guys?
Yeah, yes, mate, it does.
Okay. I know this is like crazy, super crazy syntax. Okay,
No, it's okay. I've done a bit of JavaScript, but I think it gets more. It must get more complicated when you have chains of functions and things like that.
yes, yeah. When you start chaining functions together and want to do one after the other when something happens, that's when it does get more complex.
Yeah, I
So
can imagine.
the next thing that we want to talk about is a predicate, right? And a predicate, like in English, what a predicate means is that it's basically like the state of something, right? You're talking about the state of an object or a subject, like in English, right? So what a predicate used is you pass in one parameter and you return a boolean. So in this case, we're calling our function is positive. We're passing in a parameter. In this case, when we call the function, we're passing in x, which is equal to 2. And we're saying if it's greater than 0, return true, otherwise return false. So if I step over this, you can see is x positive is equal to true, right? Because we passed in 2 into is positive, and that's greater than 0, so yeah, that's positive, right? So do we want to go over more examples of... Actually, I'll ask that question in a second. We're going to go to statements, right, which are literally the same thing, but you can do multiple lines inside of it. So if we go to a statement lambda, the only difference is when I declare I guess we don't need the action anymore. When I declare a function, right, I'm saying I'm taking in an integer, I'm returning an integer. The name of my I'm still doing the exact same function, right? I'm calling self sum, right? I'm making the exact same function, but I'm just organizing it differently, right? Previously, I'll copy it down here so you guys can see it a little bit better. Previously, it looked like this, where we just took in a parameter and added it to itself. It has a red line because the functions are named the same, but we'll ignore that for a second. Now we're taking in a parameter, and we're using curly braces, right? So we're literally making a function, right? Like you can see it has the exact same syntax as a function does, right? And in here, we're just saying the sum of them is it added to itself, and then we're just going to return that, right? Which literally this syntax is just a simpler way of doing this, right? C# allows you to basically say whatever you put in here, we're going to assume that's returned if you don't have the curly brackets. The next syntax that's nice is if you pass in multiple parameters, you have to put parentheses around them. Whereas if you just pass in one, you can see I can just pass in that parameter itself, right? So if I were to be as explicit as possible, you'd get this last solution, right? Like if I were to use all of the presumably quote unquote correct syntax without any like help, I would be taking in a function with 2 integers. I'd be returning a double. Our function would be named pow for power. We're taking in 2 parameters. That function then says we want to take the parameter 1 to the parameter of 2. We're going to store that in a variable called exponent, and then we're going to return that exponent. And when we call that function, we take 2 to the power of 3. And since we're returning that, it's going to set pow result equal to what it returns, which in this case would be 8. So the only difference between an expression lambda and a statement lambda is the syntax, or the way the language expects you to fill these things out, right? I could still put this guy all in one line, but if I put the brackets around it and I hit save, you'll see not all code paths return a value, because now this is pretending like it's a function, right? Which means I need to have a return inside of it. Whereas this is just some nice syntax to prevent you from having to do that. Okay. Does all that make sense, guys?
Yeah, I think so.
Perfect. Okay. So, do we want to do some more examples of these things so they can solidify in your brain a little more, or do we want to move on?
Yeah, maybe something like more like an actual use case
Yeah.
of actions and predicates and things like that.
So the use cases will come when we get to link. Is that our next topic? Nope, we're going to collections next. So let's say so why would you use a lambda over a function, right? I could literally, if I want to do this power function, right? I could literally write public double, and we'll call it pow because that's what we call that function, and we'll pass in an integer, and we'll call it param1, and another integer called param2, and we're going to return. We could literally copy this, and if I wanted to instead, I could just change this to power. We'll change the name of it so it's a little bit more clear. If I duplicated this and called power function, okay, it's mad at me because it wants a different variable name. Secondarily, this function is static, so it wants this function to be static, which means we're going to have to call it like this. And I did something dumb. What I do? Does not contain a definition for power. I'm doing something dumb. What am I doing? Spelling error. My bad. Okay, so the pow function up here is doing the exact same thing as power function, right? This guy is just stored in a variable, whereas this guy is actually written out in a function, right? So the beauty of that is that I could use Lambda Expressions to set a variable or to use functionality without having to create a separate function to do it. So you can see back up when I did the array.find, right? I used a Lambda expression to find what the correct value was, rather than having to loop through each of the values and say, are you equal to 20, are you equal to 20, and so on, right? I could write a quick function to do that, rather than having to break out and write a whole separate function, right? So that's kind of the purpose of lambdas, is that you can do things in the same line and make it much cleaner than having to take all the extra space and time to go write a separate function. Okay, I want to answer your question on we should do some more examples, but I think if I keep doing more examples with this func, action, and predicate syntax, it's going to make even less sense. So we're going to move on and come back to it when we get to link, because that's where you're going to find it most useful. Okay, so on to collections. So what is a collection? Okay, so I've written some extra notes. So there are two ways to group objects in C#. You can have arrays and you can have collections. We've talked about arrays. It's just a fixed length or a fixed number of objects, and they're strongly typed, meaning that when you create the array, you say, like if I were to just give you an example, I'd say integer, and then I don't know, we'll just say numbers is equal to a new integer array, and you have to give it a length, right? Or you have to pass in the numbers that you want it to have, right? Pardon my crappy syntax. So when I create this thing, this object can only ever have three things in it, right? Like when this new syntax is called, it creates an object that holds three things. It can never be modified, right? And if I hover over int, you can see it comes from system.int32, right? Like it's a primitive type, right? It is like built into it is. How do I even explain this? It's not. It doesn't come from a library or anything. It's literally a type that's built into the system. Whereas a collection is a set of classes that allows you to have generic, meaning it can hold any type, dynamically sized storage, right? So an array is fixed, right? It can only have the size that you give it when you create it. Whereas a list, for example, you can add and remove things to whatever extent you want as long as you have enough memory in your computer. And at the same time, it'll take in whatever data type, right? So we'll start with the list, right? This basically says, I'm going to create a list of objects, and those objects are going to be of type float. Our name of that list is going to be lengths. That's going to point to an object in memory that holds 0.5 and 0.75, which are floats, right? We said that. And then we're going to add three more to it, right? And the f syntax is basically, if I take off the f, I believe we talked about this in a previous stream, it'll give us an error, and it'll assume that any decimal is a double. Whereas if you add an f, that is it is nice syntax to basically allow you to tell you that this number is a float instead of a double. Because a double is too long, it can't be casted to a float. Okay, so the generic part of this list, like if I hover over a list, you can see it comes from system.collections.generic. And it is a list, and it holds t. Well, what does t mean? You'll see t really commonly throughout multiple languages that have generics. T just means when you pass something in between these alligator brackets, that is now my type. I was generic, meaning I could hold anything, but now I hold only floats. And the beauty about that is now that I'm adding things to it, you can see, like if I tried to add a string called x, it would say, give it a second to compile, Argument 1 cannot convert from string to float. Oh, it knows because we told it we're a float list, and because we have type safety, that we can't put strings in this list, because we are a list of floats, right? And that's a beautiful thing to have, because that allows you to not make those dumb mistakes that, maybe you accidentally put the wrong thing where you didn't expect it. You could put the wrong value, right? Like you could put 0.76 instead of 0.75, but you can't have the wrong type of object in there, which is like a whole nother slew of issues that can happen, right? Okay, so the beauty about collections, they're generic. You can have as many objects as you want in there, and you can change the size of it whenever, and they're type safe. So let's go through some examples of what lists can do. So this would be an example of creating a list. I could not get, so this initializes the list having these two objects already in it, whereas I could just create it like a normal class, and it wouldn't have anything inside of it. And then once I add things to it, now it would have something inside of it, right? Like this line just says, okay, Mr. Operating System, I want you to allocate memory for me to start putting things in a list. And it would say, okay. And then we'd say, hey, Mr. Operating System, I want you to, go ahead and use that memory and add something to the list. And then, the C# runtime, the virtual machine that the C# code that you runs on would interact with your operating system, telling you to keep requesting more memory for these things as you need it. It most likely requests more memory than you need, right? So that way it doesn't have to take the time to go ask for memory, right? So like when you initially add the first one, it probably is like, you know what, you'll probably need like a certain number of these, so we'll just go ahead and request 5, so that way we don't have to do this, exchange again. Okay, so we added 3 things to our list, and now what do we want to do? Well, the beauty about it being a collection is that we can for loop through the collection using this for each statement. So we can say for each float, and we'll call it length, in our collection, and our collection is named length, what do we want to do? We'll just, I don't know, I just came up with some arbitrary thing. We're just going to add up the total number of lengths, and then we could write it out, right? Well, the beautiful part about the fact that it inherits from collections is if I just hit F12 on list to go look it up, you can see it inherits the interface called IEnumerable. Ooh, now we're getting to some more interface stuff. Enumerable means it can be enumerated, or this probably is going to overlap a little bit with your guys' understanding of enums, but to enumerate is similar to iterate, right? The inheriting from enumerable, and you can see you're inheriting from enumerable T, meaning that it can hold any type. It allows you to be able to call for each upon an object, right? So if you inherit from IEnumerable, what that means is you have to include in your type some default methods. I think it's like get next index or something along those lines. Oh, okay. You have to have some reference to what your current object is, dispose of that object, and then move to the next one, right? That's how a for each loop works, right? You start the for each loop. It says, all right, what's my current one? Oh, I don't have one, so I need to move to the next one. And then when I move to the next one, what do? I dispose of the old one that I had, right? So this you get this nice for each syntax by inheriting from IEnumerable, right? Because IEnumerable requires you to have those methods, right? So what's beautiful about that is I could create my own type that's capable of being iterated over by just inheriting from IEnumerable, and then I could call for each on my own custom type, which is super cool. And you could tell it what to do when you call move next. If I wanted to do like a linked list or something, I could tell it what happens when it moves to the next value in my iteration. We're not going to go through the trouble of making our own enumerable type, but I wanted you guys to be aware of that language detail, because that is really important to understand why you're able to do the things that you're able to do. So if I were to just put a breakpoint here, and it were to write out total length, it should just print out 1 plus 2.5 plus 4, which is what, 7.5? So if I go back to program and we uncomment out our list example and we hit run, it'll hit that breakpoint here. And if you look at total length, you'll see it's 7.5, right? Because all it did is it said, for each one of our elements, let's add them to the total length, which started at 0. Okay, so the other nice part about being able to inherit from IEnumerable is that you can access it like it's an array. I want to get the 0th element, or technically the first element. I want the element at the index 0, which is the first element. So I would be changing 1.0 to 500. So if I hit run again, and we step over that line. If I hover over lengths and I look at what's inside of it, you can see it's 500, 2.5, and 4. So you can dynamically change what was in there, right? Now that I've added it to it, it doesn't mean that that is static. It's not stuck there. The other cool thing is that collections can be converted to an array. So if I go to next line, you can see if I look at the array, it's now an array with 3 elements, and they're 500, 2.5, and 4. The other cool thing that comes with IEnumerable is you can know the count of objects, because IEnumerable has a move next, right? So it can keep moving until there's no things left, so it knows the count or the number of objects inside of it, right? So if I hit F10, the number of things inside of it would be 3, right? Because 1, 2.5, and 4. I can also remove objects from my collection, right? So if I hit F10, I would have tried to remove 0.75. I had that in there when I initialized my list with it. So you can see that because I don't have 0.75 in there, it didn't remove anything. However, if I originally started this list like I had before with 0.75, it would have removed it on this line. And now you can see we have some Lambda syntax here, which is super cool. So rather than doing a normal for each loop, you can say, for each, hey Mr. Lengths list, for each one of your floats inside of you, you know, in the for each loop, we called each one that we were looping through length. In this case, we're going to call it number. And we could do the exact same thing that we did before. We could copy this down here. Actually, you know what? We're going to cheat. We could replace... I'm going to comment this out so you can see the syntactical similarities. We could replace this guy with that. These two statements are equivalent, and for each, if I hover over it, comes from list, which I assume if I go look at where it actually comes from, comes up from IEnumerable or something along those lines. But you can see I have a Lambda syntax, right? The syntax of for each knows that I'm going to take in an action, right? We're not returning anything. And that's kind of why I showed you action, function, and predicate, because if you look at the declaration in the C# scripting API that they give you, it's going to give you action. It's not going to tell you that you can take in whatever. It's going to tell you that it's an action, which you should know takes in something but doesn't return anything. So in this case, we're editing the total length variable, but we're not returning anything, right? Okay. Did that solidify some lambdas for how lambdas work a little bit, and also did the list explanation make sense as well as the collections explanation? I went over a lot without asking questions.
Yes, mate. Yeah, I understand the sort of fundamental idea, definitely.
Perfect. Okay, so we're gonna move on to another core collection. So there's 5 core collections in generic. There's a list, a dictionary, a hash set, or a set, whatever you want to call it. In C# it's a hash set, a queue, and a stack. So a dictionary is, you can think of it just like a dictionary in English. It has a word which maps to a definition, or it has a key and a value. So in a dictionary, the key would be the word and the value would be its definition, right? Well, the beauty about a dictionary is if you hover over it, it has a T key and a T value. So you can have any type for a key and any type for a value. So let's say, for example, I'm making a database of customers. Well, how would I uniquely link to each of those customers, right? Because you want to have like a unique customer, right? You only want to have one of each customer. Well, for a key, you could use an integer called ID, right? And you would have a unique ID. So the first customer would be ID 0, the second customer would be ID 1, and the database could generate those things for you. And then the second type would, so we'd make a dictionary called customers, and it would be a dictionary, and it would be an int for the ID, and we could use a custom class called customer, right? And then call the dictionary customers. So you can put in your own custom types in here, because since it's generic, since it takes in type T, it doesn't matter what it is, because all of our classes inherit from object, which is beautiful, right? Like, I can do the same fundamental operations on any data type, even if it's my own custom one, even if it's inheriting from one of my own custom ones. If I didn't have customer, I had a subclass of customer called like, I don't know, non-paying customer, because they never paid me. I don't know. I could still use that, right? Because fundamentally, at the very top of the hierarchy, it still inherits from object. So in this case, the example that I'm going to use is a dictionary of string as the key and integer as the value. The string, in this case, we're going to call our dictionary student scores. So we're going to map from a student's name to his score. So we'll say his score is like 100% in the class or whatever, right? So we can say Adam has 100%, Steve has 80%, and John has 93%. And this is if you watch the computer science fundamentals tutorial series that we have, this is a really core data structure for you to be able to map from one type to another, right? Like we could have instead we could have mapped from an integer, which would be a unique ID to the student, and to the type student, and the student could hold his name and his score and whatever else you want a student to hold. But we're gonna keep it simple for this example. Okay, so to add to a dictionary, or to create a dictionary, you create it like any other class and you pass in the 2 generic types that it needs. To add to it, it's very similar to a list. Instead of the list just passing in a value of the type that you need, we have to pass in the key and the value. And then to loop over a dictionary, you have to loop over each pair of key and values, right? So you loop over a key value pair, and the type of those is a string and integer. So we're going to loop over each student in our student scores. And I just made another arbitrary function that this thing might do and average the scores of each of the students. So we'd say the average score, and we'll add the value. So if we hover over student, a student is a key value pair, right? So if I do student dot, what student has access to, since it's a pair, it has access to the key and the value, right? The key would be the string or his name. The value would be an integer or his score, right? So what we're doing is we're adding up all the scores and then dividing it by the count of the number of objects in the dictionary, right? That's how you average things, is you add up the total number of them and divide it by how many there are. So if I run this, I'm done. I gotta comment out this guy and uncomment out this guy. When we get to this line, you can see the average score is 91. If we added up all these numbers and averaged them, I assume it would be 91. Yeah, that looks about right, because 90 and 93. And it's integers, right? So it would be a float. I think it would be 91.5. But since it's an integer, it rounds down. The other basic collections that you'll probably want to know is a set. And you can think of a set as a list, but each element has to be unique, right? So if I wanted to do, unique, I need to do this inside of a function, otherwise, it won't let me do anything with it. So we'll just say public static void hash set example. So we'll instantiate the set, so it actually has something in that memory position. And then if we want to add something, it's static, so it's going to behave weird. Okay, so if we add something to it, right? Let's say we want to add the number 1, and then we'll duplicate this, and we'll add the number 2, the number 3, and then we'll try and add the number 1 again, right? And we will put a breakpoint at the beginning of this, and we will go call this function. So we'll say collection basics dot hash set example, and we hit run. So we'll breakpoint on the first one, and when we go to the next line, you'll see all we have is an empty set with a count of 0. If we go to the next line, we will have a set with with a count of 1, and it's 0 if the object is 1. We go to the next line, we'll have 2 objects inside of it, and they'll be 1 and 2. And then same thing, we'll have 1, 2, and 3. The curious part is when we try and add 1 again, and we look at unique numbers, we still only have 3 objects, right? Because this is a set, the data type itself knows that we want to have unique numbers. So if I try and add 1 again, it's just not going to add it because we already have that in there, right? So this is a useful data structure to only hold unique things, right? So if I want to have, what would be useful to have a set of? I don't know, a set of playing cards, right? You can only have like 1 through 10 jack, queen, king, and ace, right? And if I wanted to add like an extra card to the deck, it would say, we can't do that because, we're a set of objects, right? We are unique. And so, like, if we were doing a deck of cards, if we're sticking with that example, it wouldn't be a hash set of integers. It would be a hash set of cards, and the card would have a suit, right? So, diamonds, spades, hearts and whatnot, and it would have its card value, so 1 through 10, and so on, right? And we could set up the cards class so that when it checks to see, I think it uses comparable or something along those lines. Like these data types will use something under the hood, right? So a hash set would probably use either the um, equals or compare to functions. I don't know which one off the top of my head to figure out if this card is unique, right? And so if we tried to add all 52 cards in, and then we added the 53rd card in I don't know, we tried to add two decks together, it wouldn't add it, right? Because it's not unique. But it's not unique on just one number. It's unique on its suit and its card number, right? So that's one of the nice parts about a set is that you can use it with custom data types as well and make sure you have a unique data set of whatever you want it to be unique on, right? So I could have, if we use the customer example again, well, what would make a customer unique? Maybe if we're thinking about it, maybe we don't need to compare his name, his email address, his, phone number, and so on. Maybe to make a customer unique, if he just has that integer called ID, all we have to do is check on the IDs to see if they're unique, for example. The last two are queue and stack, and these are very fundamental data structures that you should know about. We talked about the call stack, I believe, in one of the previous videos, which is literally just a stack of functions on top of each other that when they return, it pops one off the stack. So if we, just to show you the methods that it has, and we'll just call it stack example. And we'll bring this guy in. Actually, we'll bring both of them in. So if we want to create a new stack, and we're just going to call it a stack of integers. So if we do stack dot, you can see you have just a few methods, right? You have push, which pushes something on top of the stack. You have pop, which pops something on top off the top of the stack, and you have peek, which looks at whatever the top thing is, right? So really, if we if I'm pulling up here to give you a visual example, let's say we're, I don't know, we have a stack of cards, right? So we have a card on bottom, and we want to push something on top of the stack, right? Let's pretend our stack of cards, we can only touch the top, right? Like we're pretending like this is a real deck of cards, right? So all we can do is keep pushing things to the top of the stack. And if we want to get to the bottom card, we have to pop this guy off the stack, pop this guy off the stack, pop this guy off the stack, and so on to get to the bottom card, right? So the three operations that you have are to push something onto the stack, to pop the top thing off the stack, or to peek and just see, hey, what are you on top of the stack, right? And so, how would you use these? The most obvious example I can think of is a call stack. And in programming, a call stack basically says, like in our program, for example, the first thing on the stack would be the main method, right? Because when we enter a C# program, the first thing that is called is our main method. And then we would call the hash set example, right? So when we call that hash set example, it would put that, I'm going to use text here because I'm not typing that out, or writing that out. It would be hash set example. Oh, I can't type. Whatever. So theoretically what we would have would just be the main method and then the function that we called. And then when our function is done, it's going to pop this guy off the stack, and all we're going to be left with is the main method, right? And then when the main method gets to its bottom curly brace, well, then the main method pops off the stack is empty, so the program is over. And then for a queue, the queue is the exact opposite, right? You can think of it like a line at a grocery store. A queue only works with the front thing of the collection, whereas a stack only works with the back thing. So a queue is first in, first out, right? So the first thing that was put into our queue is the first thing that we're going to take out, right? So if we have 10 people line up in front of a kiosk at a mall or whatever, the first person that gets there is going to be the first person that gets dealt with, right? Whereas a stack, it would be the opposite, right? Let's think we're at a grocery store and they're putting in milk, right? Well, wait, that's an awful example. That's still first in, first out. the difference is in a queue, the first thing that goes in is the first thing that comes out, whereas the stack, the last thing that was put on top is the first thing that you have to pop off before you can get to the rest of them, right? So a queue is going to have very similar operations. It has NQ and DQ, meaning to put it at the front and take away from the front, and then to peek at whatever the one in the front is. And then it has some other ones that aren't terribly useful or aren't fundamental to the data structure itself, like the count or the to array. Like those wouldn't be in every language, but in just about every language that you have a queue, you'd have NQ and DQ and peek, and then maybe clear. But to have the fundamentals of the data structure, all you would need is NQ and DQ to bring something to the front and take it off the front. Whereas the rest of them are kind of convenience, right? To clear literally just means you'd keep DQing until there's nothing else to DQ, right? Okay. Does that make sense? Does what we've talked about so far make sense?
Yeah, dude. I was wondering if it means that the main method it can't get removed until everything else gets popped off the stack, right? How does a program like quit or like terminate before like out of like a higher method up the stack?
Ooh, that is a really good example, or a really good question. So let's it kind of depends on the runtime that you're working with, right? So let's draw our same example. We're gonna have our main method on bottom, and then we called a function, and that function called a function, and that function called a function. And in this function, maybe you're in Unity and you typed in application.quit, and what that would do is kill the application. So okay, bear in mind that I don't know how it would actually work. I have two ideas of how it would work. One would be that it would just say, Mr. Runtime, we don't need this anymore, kill everything, right? Like, maybe you held the power button on your computer and it just wiped your RAM clean, right? Like, it just literally deleted everything. The other way is it would systematically just keep popping them off the stack until it's off, right? That way it would execute, like, cleanly, right? That was a really good question, though. I will answer that in the Discord. I am actually curious about that. I want to go look into that. Like how the actual runtime that is running your C# code works is not something that I've delved too deep into, but it's very interesting to learn about because you get to learn all sorts of cool things about why your program might be misfunctioning.
Yeah, I have one more question. Can you nest dictionaries or whatever? So have like a dictionary in a dictionary kind of thing.
Like
A bit like
so,
in JSON.
like
You know
this.
what I mean?
I'm sorry, you're behind on the stream, but yes, you can. So you could have a dictionary with the key as a list of strings and the value as, I don't know, another dictionary that is a integer and an integer. Because
Sure.
a
Yeah.
dictionary has t key and t value, meaning that it can take in anything that inherits from object, right? So you could keep nesting these things as far as you wanted to, but as soon as you start nesting them, I'd highly recommend breaking it out into its own class to handle those things for you, or its own struct. Otherwise, it's going to get really complicated and messy really quick.
Oh, so you put the whole thing into its own custom type or class. Is
Yeah.
that what you
So
mean?
yeah, hold on. We'll do an example here. We'll just create a class inside this one. We'll call it I don't know, dictionary holder, and it would hold a public list of integers, and we'll call it, I don't know, ints. And so we could have it hold that class. I mean, it's going to freak out the rest of the program because it's assuming those are the keys and values. But if we change this guy to dictionary holder and this guy to dictionary holder, it would work just fine. Okay, I take it back. These guys are strings. Don't ignore that, but you get the concept. And on average, a dictionary, the key is some unique ID. So the majority of the time, um, I don't want to say the majority of the time. Most the thing that conceptually makes the most sense is that the key would be an integer because you can have just unique numbers, right? And then the value is some data that integer is mapping to, right? So in a database, more often than not, the integers would be numerical and they'd automatically count up for you depending on the database that you're using. So you'd have like 0, 1, 2, and so on. And then the data that it could hold, we could say public class student, and it could have a string name, a integer for his percentage for his grade, and so on. And so the dictionary would really just hold students. That way it's actually holding some meaningful data. I don't know, you have to pull out like something actually out of the values if these were public. So you could like pull the percentage out of the kid's grade, or out of the kid's out of the student's data type. You could pull the percentage out of it, and then you could actually like, I don't know, create a constructor that would take in the name and percentage, so it would actually be set to something. Whereas right now they'll just be empty. But yeah,
Yeah, this is such a different way of doing things to like scripting languages.
yes, and that's why I like it, because this sets up the data and you know what it holds and you can make expectations based off of that, right?
Yeah, you like predefine everything, and then it kind of works exactly how you want it to work.
Exactly.
Yeah, but I guess it takes longer to write initially.
It may take longer to write, but it is much easier to debug. I mean, I haven't done a whole lot of JavaScript, so that's a very blanket statement that I probably shouldn't say. But from my experience, it's much easier to debug knowing what the types are inside of it. There's not as many like syntax errors. Like if I accidentally tried to put like 3 inside of the value of a dictionary in dynamically typed languages, it may not catch that I made that typo and tell me that the type is wrong. Okay, I'll leave that for now. Moving on. So we covered the very basics of collections. Let me scroll back up and make sure I didn't miss any notes. Nope, looks like we got it. And just so you guys are aware, system, it comes from like the .NET architecture. So like these are like the inherent libraries to .NET. And then collections is all the list of collections. We missed a couple. There are sorted versions of the list, set, and dictionary. So when you add, like if you were doing a list of integers and we added another list item, when we add it in there, it'll automatically put it in order. So adding to that list would be slower. But if you wanted to pull something out, it would be quicker because it's sorted, so it could search through it quicker, right? Or if you wanted to print your data ordered, it might be easier for you to use a sorted list than have to order it when you try and print it. It kind of depends on the operations that you're going to be doing with the data, right? So if you're going to be doing a lot of adding to the list but not a lot of reading from it, then maybe it's better to use a regular list. Whereas if you're going to be doing a lot of searching through the list versus adding to the list, it might be a lot better to use a sorted list because that operation that you're going to be doing more is quicker. So understanding how we talked about this in the data structures talk, but understanding how these things function, like what their time takes for adding, removing, or sorting is important, because then you can use the correct one for the correct task. Okay, on to link. And link is a crazy set of operations that you can do with data. So, what does link mean? Link stands for Language Integrated Query. Awful acronym. Yeah, I know. Microsoft is known for those. So what does link do? Link is it's basically a query language, like think like SQL built into C#. And so they can filter data, they can sort data, they can group it. They can do more things, like they could map things from one data type to another, right? Like if we did a for each loop on our integers, we could map that to, I don't know, strings, right? We could say the integer 1 maps to the string 1, for example. But one of the coolest parts about LINQ is that it's a way to query multiple different data sources. So you can query objects in C#, you could query data from databases, and you could query XML, right? So you don't have to use SQL. You can just use LINQ, and you have one set of syntax that allows you to work with all these different types of things. So it's kind of unified, right? So it makes it so that you only have to learn one syntax, and once you know it, you can you can work with all the things that .NET supplies for you. I don't want to say all the things because you may have to work with like JSON and whatnot, but all of the main modes of working with data. So I just have some very simple functions that use LINQ. So we create an array of numbers. It just holds 2, 3, 4, and 5. And let's say what we want to do is we want to square each one of these numbers, right? So what we want to what the result should be is an array with 4, 9, 16, and 25. So what we can do is on the numbers array, it has a method called select. And you can see select comes from IEnumerable. IEnumerable is what allows you to loop through it, right? So if I took out these using system.link up here, if I took that out, you'd see the select method doesn't exist, right? It doesn't know that it exists. So LINQ is kind of this bridge between the array that we know and new operations that we can do to it, thanks to the querying that it gives. So what this says is select. So it's basically doing this for loop, and I want to select each one of my elements and do something with it, right? So the description that it gives you is that it projects each element of a sequence into a new form. So in this case, we're going to take in a variable called x. We could name it whatever, right? It doesn't matter. This is that lambda syntax, right? This is just the name of the parameter to that function. And what do we want to do when we return? Well, we want to multiply x by x, or take it to the power of 2, right? So if you hover over select, you can see it takes in a function, right? Actions don't return anything, but functions do, right? So you can see this function takes in an integer, and it returns an integer. So if I go back to program, and I uncomment out this first function called getSquares, and let me close out of the rest of these guys, and let's put a breakpoint right here. Actually, we'll put it at the beginning so we can step through. So we create our numbers array, so we can hover over it and we can see what's inside of it: 2, 3, 4, 5. And now when we try and select through the numbers, you can see when we're done, the squared numbers, the output of this guy, is, so the weird part is what select returns. If I hover over, God, it doesn't work while it's running, my bad. If you hover over select, what does it return? Come on. It returns an IEnumerable that's holding integers, right? So it's returning something that can be looped over that's holding integers. And the basic flow of LINQ is that you have a data set. So in this case, we have an array of integers. Then I think I wrote it down here. You need a data source, you create the query, and then you execute the query, right? So we have our data source, we created the query, but the query doesn't execute until we loop over that IEnumerable, right? Right now it's just a list of numbers, but we haven't done anything with it. So to loop over it, we can call string.join. And what join does, if you hover over it, you can see it concatenates the members of a collection using the separator, right? So in this case, it would take each of the numbers inside of it and print out each number with a space in between it. I mean, we could change it to a comma or something, right? So it would literally print out this, but each of the numbers squared, right? So if we just hit run, you can see it prints out 4, 9, 16, and 25. So this guy set up the query to make that operation, and by calling string.join, we loop over each of those numbers in that list and concatenate them, meaning we smush them together with commas. And by looping over them, that executes the query, right? That executes this query here. So what's kind of nice about that is the query is only executed when you loop over, right? So you can set this thing up, right, and say at some point we will do this, but it won't eat up that memory, eat up that processing time until you actually loop over it, which is kind of cool to learn. So what I did next is I took that getSquares function and I broke out the select into a Lambda expression. So instead of just saying x goes to x times x, we say a parameter is going to return whatever the square of that parameters is. And what is this square numbers thing doing? Well, it's a function that takes in an integer and returns an integer. That function takes in an integer called x and multiplies it by itself. So these two functions are equivalent in their functionality, right? They're just written in different ways. Why would you ever do it one way over the other? I would never do it this way. I just wanted to show you guys that it is possible, because what select takes in is a function, right? That's literally what it takes in. It takes a function that takes in an integer and returns an integer. So I could store that in a variable and use it later. If that is more readable to some people than others, that might be useful. Or I could declare this function somewhere and use it somewhere else, so that way maybe it's more reusable, right? Okay. Does these two functions make sense to you guys?
Yeah, man. I'm just still thinking how you'd actually query a remote data source.
Oh, so okay, so right here we're just kind of setting the data to whatever we want, right? We're just kind of like statically saying, this is our data. Well, we could do,
Yeah, yeah.
if we're doing like a web application, this is not the syntax that it would be. I'm just trying to give you an idea of what it would look like. We could say like SQL connection dot get data, and then I don't know, pass in the database name and the table name, like customer data or something. And this guy would, populate our array with that data. This isn't how it would normally work. You'd have to make like a legitimate request, and we'll look at those in the next stream. But just to give you an idea of what it might look like.
But yeah, once you get it from the endpoint or whatever, the logic's the same as we got here, basically.
Exactly.
Yeah. Okay.
Okay, so now we're going to get a little bit more complicated. What we want to do with this function is get the number of evens in this array, right? So we have 2, 3, 4, and 5. The number of evens, we have a 2 and a 4, right? So there's we should be returning 2, right? So what do? We want to get an integer called even count, which is the number of evens, right? And so we're going to say numbers. We want to, the count function returns the number that represents how many satisfy the predicate, right? So our predicate is a Boolean, right? So we're saying modulus 2, right? So we're saying if you're divisible by 2, then we're going to count you, right? So for 2, it would be 2% 2, and that would return 0, right? So this statement would be true, so that's going to add 1 to our count. We're going to go, the next guy's going to be 3, and its modulus is going to be 1, so this statement's going to be false, so that won't add 1 to the count, and so on, right? So if I go and I run this function, and actually I don't even need to put a breakpoint in there. Oh, I called the wrong function, my bad. I printed out the get func squares because I was going to show you that it prints out the same thing, but I think we can all see that it does the same thing. I can run it if you guys want. Okay, so you can see our even count is 2 right now, right? So if I go, if I just continue, you can see what it prints out. Hold on. It doesn't hit the console.write line. I don't know why. That's curious. We ran into this last time where I had to like make a new project because the console.write lines weren't hitting. I'm assuming I'm doing just something dumb. Basically what it would have printed out is there are 2 evens in, and then it would have done a string.join, so it would print out each of the numbers inside of it. Because you can't just do numbers dot toString, because that would print out like it prints out something like array like 4 or something like that, or system.array I think is what it prints out. It prints out the type, right? Because for normal classes the toString is just the name of the type itself, right? So what we have to do is we have to loop through each of the numbers and join them together by a comma and then print them out, right? And I believe it's the same goes for lists. You have to do this. Okay, so the next one, we're going to this is going to look more like SQL. So there's 2 ways to do link, right? You can call one of these methods on an IEnumerable, or you can use the actual query syntax, right? So we have just a list of scores, and I was keeping the same idea of like test scores, right? So you have like a 55%, a 99%, and so on. So what we're going to do is we're going to create this query that just holds an IEnumerable of scores. which are integers. So we're going to say from score, and we're going to say score is what we're calling our parameter in this case. So we're saying from score and scores, which basically says for each one of the scores in our scores array, we want to only get the scores that are greater than 80, and then select those and return them into our IEnumerable. And then for each one of those scores, we want to write them with a space in between them. We could have done the string.join, but I wanted to show you another way. This is equivalent to the string.join with a space instead of a comma. Except for it'll have a trailing space afterwards, which is fine. It would be equivalent to this with a space afterwards. So if I go and I run this guy, it's not going to print anything because I did some weird setup thing that I don't know what I did, I'm assuming. Maybe it's because I didn't close out of the console. Haha, that's what it was. Okay, so you can see it's only going to print the scores that are greater than 80, but it's not going to sort them, right? So 55 isn't greater than 80, but 99 is, so it prints it. 100 is greater than 80, 72 isn't, 93 is, 85 is, and 79 isn't. So you can see this query syntax allows it to look like SQL. If you haven't used SQL before, this is kind of what it looks like. This is how you like query a database for data. You'd say from this table in this database, this is how we want to filter the data, and then we want to select these columns from that database. So like if you're looking at like an Excel spreadsheet, you'd select which columns you want from that spreadsheet. So just to reiterate, we create the data source, right? Or we could get this from a database. We create the query, and I wrote these notes down because I wanted to re-hit the point that since all of the collections inherit from IEnumerable or IEnumerable T, they are capable of being iterated upon, meaning they're capable of having link queries upon them. So an IEnumerable interface exposes an enumerator, right? So the interface allows you to have that method for you to iterate upon it, which allows you to iterate upon it, which allows you to make a query upon it. And then to actually execute that query, you do that iteration. Okay. I feel like we're going really quick and we're making good time, but I also feel like there could be some confusion, so feel free to stop me for questions here.
Mate, you're good, I think, yeah.
Perfect. Okay. Now we're going to get into the stuff that has stumped me for a while, and I actually learned quite a bit about this week to make this talk more useful. So we're going to look at delegates. So a delegate is, if you've ever used C++, it's similar to their function pointers. So really what a delegate is it's a pointer, or it's a reference to a function, right? So what we're saying here is I'm going to create something that can hold references to functions. What type of functions? Functions that have a void return type and take in a string. It doesn't matter what the variable name is, that's just what you call it. I take that back. It does matter, doesn't it? Will these guys error out? It doesn't. Okay. It only looks at the method signature, which is the types of parameters and types of the return. So delegates are commonly used to define callbacks. So like let's say, for example, I like using Unity as an example because they were the first place that I understood callbacks. So like if you tell Unity to quit running, you get a callback that you could say, when the application's shutting down, you could save your data, like your player data, for example. So a callback would be after that function to start quitting has been called, you can do things before the program shuts down, right? So that would be like an event that was raised, right? So the event would be application.quit, and the callback would be, on application quit, you can do this thing. So I created this function called Delegate Basics, and this is just like the entry point. The setup of this doesn't really matter. So we create an instance of our delegate, right? So our delegate's name is print message, and we're creating a handler for it, right? We're going to say we want to handle what happens when this print delegate is called, right? And so what do we want to do? We want to call the method for print delegate. So it's weird setting one function equal to another. And what's even more weird is we do the plus equals syntax, which is what you normally do to like concatenate strings or add numbers to each other. So what this is saying is we're creating the delegate and we want this guy to listen for when that delegate is called. but we also want this guy to listen to when that delegate gets called. So a delegate is really a list of functions that when you call it, it tells those functions to do something. So when I call the delegate, so the name of the delegate is print handler, and I'm passing in, I am handling a print, right? Because our delegate holds a string. What it's going to do is it's going to call both of the methods, right? Because we added them to the list that are going to be called. So this the first guy is just going to print out whatever he wants. He doesn't care about the message. The second guy is actually going to print out the message. And then what happens is I remove a listener and I say this function no longer wants to listen to what's going on. Uh, and then I call it again. So what should only happen is that we should use the function that wasn't removed, right? So if we okay, I did uncomment it. We have to close out of the console. If we hit run, we will see that it works precisely as expected. So you say print message delegate was called, which was this first function, right? The so what happens when we call this function? It says, "Hey, Mr. Delegate, all of your functions, I want you to start running at the exact same time. They're synchronous, right? It says, Mr. Processor, you have multiple threads. Go run all of these things at the same time, and whichever one finishes first, right?" Um, so the print message delegate was called was printed out right here, right? That was the first thing that was printed out. And then we said I am handling a print, right? And that was passed in through this function, right? And then we removed the delegate, the method for print delegate, which is this guy. So print message delegate was called, would not be printed again. What's going to be instead printed is what we passed in, because the other function is going to take in that message and print it out, which is I only have one listener now. Okay. I feel like that's going to be a very abstract way to explain these, so feel free to hit me with some questions.
It's always in that order, isn't it?
What's
That
always
they
in?
get that the callbacks get sort of executed, isn't it? Yeah.
Like how this guy was printed before this guy?
Yeah, yeah.
That's just because, okay, they're called synchronously, but the other guy's synchronous thread was started first, right?
Okay. That's what was a bit.
So
Yeah.
if this function happened to take longer, the other one could have finished first, right? It's just that this one, like the compiler came through and we executed this line, and then we executed this line, right?
Oh, right. Okay. Yeah. So it just happens that because they're basically the same, they're doing basically the same thing. It
Yeah.
happened this way, but if they were different
Let's do
hands at
this.
different times, yeah.
Let's just put like a deep for loop in front of this guy just to show that that works. So say for int I is equal to 0, I is less than, I don't know, 100,000 I plus plus, and I don't know, we'll just increment an integer. So if I hit run now, it's not going to work because I didn't close out the console last time. Am I a filthy liar? I could have swore I read that they were called synchronously. Hold on, go into the documentation. Maybe this just didn't take long enough?
You maybe need to add a few more zeros.
That's what I'm thinking. No?
It's always surprising how fast.
I know, you did it like 10 million times?
I guess it's not doing much each iteration, but
Fine. Maybe that'll take long enough. I didn't close out of the... No, it does look like it still goes first. That is... Alright, I may be a liar. I will have to find the... Maybe it was events. Oh. I wrote it down. If an event has multiple, okay, my bad, I confused myself. It's events that do it synchronously, not delegates. We'll get to events in a second. Okay, so besides me making a fool out of myself, does that make sense?
Yeah, I got the basic.
Okay, and we'll get into the usage of delegates with events, right? So a delegate basically says when something happens, tell the people that are listening to that delegate to do whatever they're supposed to do, right? So the most common way that they're used is with events. So if we move over to our event explanation, so events enable a class or object to notify other classes or objects when something happens. So what happens is the class that sends the event is called the publisher, right? So they're publishing an event. The class that receives or handles the event is called the subscriber. They're subscribing to the event that's happening, right? I like how they use normal words that make sense to the underlying action that's happening. So events are typically used for user interaction. So like if a button is clicked, you'd have an event that fires called button clicked, and then you'd have a method that responds to say, I don't know, update the number on the screen, right? So what we have here is we created a delegate called custom event handler, right? We're just handling some sort of custom event, and we're gonna this is supposed to be sender. So what's gonna happen with the custom event handler is when that custom event is raised, or when somebody says, "Hey, Mr. Event, like you're going on." In some case, it could be when you're clicking, or when you hit a key, or when you hit a button. We want to send to them whoever sent that event. So like maybe you want to say, if this button sent to this event, we do X, and if this button sent, we do Y, right? And then we want to send whatever arguments come with it, right? So if we have 3 buttons and we have button 1, 2, and 3, maybe we want to pass integers 1, 2, and 3 so we can respond to it accordingly. So we have the delegate that people can subscribe to. We have the event that we have the delegate that is the holder of the function, and we have the event that people subscribe to. And so we can raise the event and pass in a message. And so basically what we say is if the custom event is not null, meaning does the event have some sort of subscribers, then we want to call that custom event. So we want to call that function, and we want to pass in this, meaning this class. So whoever the publisher is, right? We want to pass and pretend that we are the sender or the publisher, like we're the one publishing this event. And then we're going to pass in some custom arguments, which is, if I go to my custom event args, I just created a class called custom event arguments, and it has a constructor that takes in a string, and all that does is set the event message equal to that string. So we just have a string called event message, and it can be get, but it's private set, right? So it's a read-only property, right? So it can only be set from the constructor. So if we go to our event manager, what it does is it creates an instance of our publisher. It says, Mr. Publisher, your custom event, right? So if we go back to publisher, our custom event is an event, right? That is the type of thing that it is, right? I want to add a subscriber, right? So we're going to call it custom event subscriber. And I want to add another one. So this is very similar to how we added listeners to a delegate, right? But in events, it's called a publisher and a subscriber. So what we want to do is when the user inputs something, right, when we read a line, so when user types something and hits enter, we want to set the user input to what they put, and we want to raise that event and pass in what they typed. And so what should happen? The subscribers are going to say, the sender is this guy, the arguments that are sent are this, and here's the message that the user sent. And the other one is just going to say, I'm another subscriber, so that we can show that 2 events are happening. So if I go back to our program and I uncomment this guy out, and I hit run, we will see, no we will not because I didn't close out the console. I did something wrong. What did I break? Do we hit our breakpoint? Oh, it's reading from the user input, right? So if I type in something, right, and I hit enter, you see it was waiting for me to read a line, and now that I've read a line, it raises the event, right? So if I hit F10, I'll keep stepping. And where do we go? We go, now that the event manager has been created, it popped it off the stack and we ended the program. But we can go see what happened if we pull back open the event manager. Here's what I typed in. And then the first subscriber was the custom event subscriber. So it printed out the sender was the name of the object, which is publisher. The arguments, it's just going to print out the name of the class, right? The custom event args. And then you print out the args.event message, the property, because we saw it was read only, so we can read from it. And then we saw just I'm another subscriber, right? So I'm another subscriber. So what we could do is we could duplicate this, and we could remove a subscriber. I don't know, let's call this user input 2. So what would happen in this case is we put in test message 1. The sender is publisher, the arguments, and the message was test message 1. And then we had I'm another subscriber. And then it's waiting for us to read a line. So we'd put test message 2. And you can see I messed up. It didn't send the right message. When we raise the custom event, it creates a new custom event args with the message that we sent. Oh, I forgot to put, this user input is still pointing to the one that we put before, so we change it to user input 2. My bad. We'll just make the inputs like drastically different so it's readily apparent what's going on. Okay, so the event that we raised has subscribers, right? Which all they do when that event happens is they print out what happened, right? Or what that message was. So this would be really common. The reason we like these, or I don't want to say the reason that these are useful is if you have an event-based system like a UI, when you press a button, like you don't want to sit there and every second check if somebody pressed the button. You want to know if somebody pressed the button, just do something afterwards, right? That way you're not wasting extra processing time. So, for example, I don't know if you're playing a game, right, and you press the W key to start moving forward, or you move your mouse, you'd have an event that listens for that to happen, and when you do that thing, when you press W, it would start moving your character forward, for example, right? Or man, there's so many ways that events are used. The beauty of it is that you can create almost like a central messaging system that like so for example, one of the APIs that I worked on for my old job, we had this like pub sub manager, publisher subscriber manager, that when a message was sent in, it would figure out what type of message it was. So it would be like it's updating the data, or it's telling me that one of my hardware failed. It would decode what that type of data was, and then it would send out the message to the appropriate people. So like, if a piece of hardware went down, it would start sending alerts to different UIs that are subscribed to that, right? Does that process make sense?
Yes, mate. Yeah, I bet it gets hard to like track everything at scale, but yeah.
So that should cover all of the code of this tutorial. The last thing that I wanted to talk about was documentation. And if you're confused after all these things that we've talked about, in the further streams, we're going to go more example based, right? I'm not going to go over each and every one of these individual concepts again. I'm going to bring a problem to the table, and we're going to use all the knowledge that we have to figure out what the correct solution is based off of all the things that we know now. And I think that'll help these things stick in a lot better. But as far as documentation goes, the beauty of C# is that they kind of have a documentation system built in. So if I were to go to Publisher, for example, I want to create, like when I hover over what would be a good example? If I hover over IEnumerable, you see how it gives you like documentation down here that tells you what IEnumerable is for? Well, if we're writing some code, or we're writing any sort of application that maybe other people are going to use, right? If we're writing an API that says, here's the data that you need to send in, here's the data that you're going to receive, documentation is super important. So that way you could make a website saying like, here's how these things work. So the cool part about C# is if you type 3 slashes, it'll automatically put in this summary for you, and I could say this class is a publisher example. And if I hit save, and now if I hover over publisher, you can see it automatically in the IDE gives me this documentation, right? So now I could go document each of the methods. So when I'm in event manager, for example, if I hover over publisher.custom event, I could just have like a little readout of what it does. So that way, if people are using my code, they don't have to go, look into my code and try and, understand what it does. I could just put comments that explain how all these things work. So I could I should be, this is a holder for the custom event publisher. And if I go back to here and I look at custom event, you can see it automatically puts the text down here. And the other nice part about it is that you could use a tool like Doxygen. And what it does is it looks through all of that documentation that you've put here, that you've put in your files, and it automatically creates documentation for you. So if I go, a good example of this would be if I go to dev.api.oneleaf.com, you could see for user, for example, a user takes in an email, which is a string, a password, and a string. What responses can it give you? A user successfully is registered, or a validation error saying, maybe you didn't pass in the right type of data. And this stuff we didn't make this website at all. I think we used Oxygen. No, we used Swagger, and it automatically generated this entire thing for us. So if you have good documentation throughout your code, you don't have to explain how things work to the people that use your code, because you can have things, just generate documentation for you. On the other side of that, if you make really good variable names, function names, and class names, and like if I say like publisher or instead of publisher, it would be like custom event publisher, right? Because that's the name of our event, right? Like if I rename the class to that, maybe we don't need as in-depth documentation up here, but you probably still want something. But the important part here is to manage not only documentation, but how you're naming everything and how clean your code is. So that way, when people are using your code, or you have someone on your team that has to use some of the code that you've written, that you make sure that they can do it in a feasible amount of time without having to read through every line and understand what's going on. That covers everything I had prepared for today. So if we have any off-topic questions or questions that you guys have written down during the stream, now would be the time to ask.
Yeah, so I had one for like practicing or just understanding delegates a bit more, because they are confusing.
Yeah.
Would there be a good way of like good little thing, a good program to like try and write for sort of like getting to grips with it? Just off the top of your head.
Yeah, I'm trying to think of like practical examples that like aren't meaningless, I guess.
Yeah, that's what I'm looking for.
So the hard part about this is like in a console app, they don't really make sense. Actually, I got it. All right, here's what we're gonna do. We're going to make a really basic text adventure. So what we do is we go to our event manager, and we'd have a while loop, and we'll just call it while true, because this is gonna be like our core game loop. And we're going to ask the user for his input. So we're going to read a line, and then we're going to raise the event telling the game that something has changed, right? And so we're only going to have one event for now, and we'll say the subscriber will be player input subscriber. And so what we're going to do is we're going to say, based off the arguments that come in, we're going to say if args dot, if the event message is, I don't know, start, then what we could do is we could send off events to somewhere else to start setting up the game and printing things out, right? So now you don't have to have this really giant if-else structure for, you say, if they put A, if they put B, if they put C, or if they type X, Y, Z. do this. You can have events that control the flow of your game. Does that make sense?
Yeah, so you can pass in anything there.
Yeah, and what I would highly recommend doing is instead of doing strings, turn it into an enum. So you'd have public enum, I don't know, input values, and you could have, I don't know, start, move up, move down, and so on. It doesn't like my enum. Oh, I put it inside a function. I'm dumb. And then you could say if the event message equals what did I call it? Input values dot move down dot toString. Right. So now instead of in quotes move down, that lets me have a typo, right? So now you could lay out all the inputs that are possible and do like a switch statement over them to have people respond accordingly. And so what you could do is all this subscriber would do is it would switch over all of the possible inputs and send a message to the correct subscriber to say, hey, he wanted to move up. You go do the thing that tells you to move up. Delegates and events are really useful for first-person shooters. A lot of my examples are going to come. A lot of my practical examples are going to come from gaming because that's what I do as a hobby. So if I'm for example playing a first-person shooter and I have a few options, I have the WASD keys to move forward, back, left, right, and I have I don't know the R key to reload and the left click to shoot. Well, what could happen is I could have a listener listening for all those inputs, and if the player presses reload while they're shooting, for example, you could check the state of the player, and the state could be you could have an enum for states, and you could say public enum player states, and it could be like idle, running, shooting, and reloading. And whenever they pass in the correct input, right? So you could check if, like, if they're pressing the W key, for example, you could set the state of your player to the new one, right? So if you're shooting and you hit the R key, it would change you to reloading. And after a timer, it would change you from reloading to idle if you're not holding anything else. Or like if you're trying to, maybe your game only allows you to, maybe it has like a walking. Maybe it doesn't allow you to run while reloading. So when you when you are in the reloading state and you try and hit the shift key to run or whatever, it would check if you're reloading and say, hey, you can't run, just keep walking. I hope those are all useful examples. I know you're probably 15 seconds behind, so I'll wait a bit.
Well, yes, mate. No, it makes sense. I need to kind of play around with it myself, I think, really. So
Yeah.
instill everything. But yeah, no, I think I've got a sort of decent idea.
Delegates and events like finally clicked for me today. Like I've been able to use them, but I like walking through each of the steps to set these up like locked them into my brain. So I'd recommend just like trying to make something work. And it's kind of hard to like do what you want without having some examples in mind. So I'd recommend Googling like, I don't know, C# delegate examples or something like that and trying to make it fit your use case.
Yeah, sounds like a plan.
But yeah, next stream we'll be looking at HTTP requests, async, and then after that we'll start looking at making an actual project so we can start making use of all these things that we've learned. But yeah, thanks everybody for watching. I hope you learned a lot. I hope I didn't leave you with more questions than you started with. But yeah, have a great night, everyone. Thanks for joining me, Max.
Cheers, mate.